The pioneering work of California 3D printing expert Carbon is something that we've covered on a regular basis. The company introduced a line of 3D printers with its patented digital light synthesis technology a few years ago, and has partnered with Adidas to develop a range of cutting-edge 3D printed sneakers, amongst other groundbreaking projects. Another impressive application of Carbon's technology was carried out by Hornet Racing, a student engineering team at the University of California, Sacramento. The team used 3D printing to revolutionize the design of a racing car it was building for a major competition. The Formula Society of Automotive Engineers, SAE, holds a competition between different university teams every year. It has strict guidelines which are intended to encourage creativity, challenging students to come up with innovative ways to tackle design and engineering problems. In 2017, the SAE demanded that all stock throttle bodies in engines must be removed, and replaced with a single throttle for all 4 cylinders. Additionally, guidelines dictated that a 20 mm diameter restrictor had to be placed behind the single throttle. This performance constraint on Hornet Racing's engine reduced its potential airflow and seriously limited its power output. The vehicle used by Hornet Racing had a Honda CBR 600RR Series 4-cylinder engine, which usually comes with 4 individual throttle bodies, one for each cylinder, that are each 44 mm in diameter, and are placed very close to the cylinder head. Competition guidelines demanded a major restructuring of its air intake system, as did the airflow problems that had affected the vehicle's performance in previous years. Poor airflow often led to delayed or unpredictable acceleration, which made the driver's job a lot more difficult when trying to control the vehicle. The team decided to make use of Carbon's 3D printing technology in order to improve the design of their engine. Most important was that the shape of the engine intake manifold had to be changed, in order to improve and optimize the flow of air through the engine. Specifically, the team's main goals were to create components that promoted minimal boundary layer formation, to allow for smooth air airflow. They also wanted to integrate the fuel injector ports into the base of the intake runners, tubes that connect the plenum with the cylinder heads, in order to achieve minimal flow turbulence. An overall weight reduction, and a simplified assembly process that would leave less margin for error, were also identified as factors that could contribute to improved performance. The use of Carbon's digital light synthesis 3D printing technology meant that the team had a whole new range of possible design geometries available to them. Going through a huge number of different geometric iterations to find the perfect shape would previously have been much too time-consuming, but the whole process was significantly streamlined with a manufacturing process based on direct realization of a 3D digital model. Also, the assembly and production costs for the finished design would have been prohibitively high with the conventional manufacturing processes used, which involved extensive tooling, carbon fiber molds, and welding. Printed from Carbon's proprietary RPU70 material, Hornet Racing's new design for the air intake manifold was a bulb shape, measuring only 7 inches in length. This replaced the previous 2-foot-long diffuser, and the large plenum which was over a half-gallon in volume. The overall design was inspired by supersonic jet engine shock cones, which are capable of regulating air intake based on their shape. The team combined functionalities of both the diffuser and the plenum in one, by designing a spike-like flow split within the bulb structure. 3D printing also meant that no welding was involved, and the weight of the new air intake component was significantly reduced. The air intake manifold is placed relatively high up in the car's body, which means that its weight has a major effect on the car's roll center and other vehicle dynamics. The 3D printed component weighed 50% less than the one used by Hornet Racing in 2016, and it contributed to improved vehicle handling and a better overall driving experience. With the help of Carbon's 3D printing systems and materials, Hornet Racing performed better in the SAE competition than it ever had before. The HR 2017 car finished in 16th place overall, out of a total of 80 teams from universities all over the world.